I'm Wymann.
I'm Meckley.
I'm Nolan Carr, and this is Garret Janke.
And we are Slow and Steady Wins the Race. For our project of automated chicken coop door, we had to ask many questions, including what does a normal chicken coop door look like? What are normal chicken habits? And how can we automate the process of opening the door?
For the imagined portion of our project, we began by researching typical door opening mechanisms, but were left only to find typical elevator mechanisms as well as pulley systems, and we felt that these would not work effectively for our chosen design, so we were left, in conclusion, with this simple nut and bolt system.
We found that the simplest and most cost-effective way of integrating all these sensors into one system was with an Arduino.
For our original plan, we were going to have two threaded rods, one on either side of the door, which would spin simultaneously, raising the door to the desired height.
Following with Plan 1, we moved into the Create 1 process where we've built our first prototype. This is the one side of the threaded rod system, but after looking further into the logistics, we decided that this model was not the most effective option due to the complexity of having two motors spinning simultaneously, as well as maxing out our budget. After negating Plan 1, we went back to the drawing board and starting from scratch with Plan 2. So this time we decided instead of using two threaded rods, that we would use only one positioned in the center.
This is better than Plan 1 because we only have one rod, so we don't have to worry about synchronizing two motors and worrying about if one is faster than the other.
Throughout both planning period 1 and 2, we were brainstorming possible ideas for motors to use on our project. Initially, we decided that a window motor would work well, but upon further research decided that it would not work well due to the difficulty of tying it together with our Arduino module. Furthermore, we decided to look into drills, and we saw that Amazon had some really cheap drills that would fit well within our budget, but then again, they were also difficult to tie together with an Arduino and would require us an expensive motor controller. Finally, we decided to settle on a cheap motor that was sold on Amazon, typically used with robotics, and it was easy to tie together with the Arduino and ended up being a perfect fit for our module.
Following our second planning phase, we began creating our actual product, which included our single threaded rod design as well as our Arduino triggering device.
After acquiring the motor and all of the sensors that we needed, we began the construction phase of the Arduino. So at the top we have the motor connected to a control board that powers it, and this is controlled by the Arduino. The Arduino also connects to a remote control sensor on the side, a light sensor at the top, and down here there's a magnetic sensor that can detect a chicken. And it's powered by a cord on the side. In order to display our sensors at work, Liam's going to shine a flashlight on the photo sensor, which is going to simulate the levels of light outside during the day. So when Liam takes his phone away to simulate it turning back to nighttime, the door is going to go back down. To protect the motor from burning out as it goes down, there's a safety system implemented so that you can't make the door go down once it's already down, or make the door go up once it's already up. So if it's in the down position right now and I press the down button on the remote, it won't go down again, but it still can go up.
After completing construction of our chicken coop door, there are several things that we still think that could be improved if we were to make the chicken coop door again. And the number one thing that we had on our list of possible improvements was the motor speed. The door takes a combined 5 minutes to go up and down, and although the chickens are in no rush, this is still a slow process. And two aspects that could really help with the speed of this door are the weight of the chicken coop door as well as the power of the motor. Due to our budget, we were forced to purchase a motor that did not have quite a lot of power, but if we were to have a larger budget in the future, we could purchase a stronger motor. And the same goes for the door. If we had a higher budget, we'd have access to lighter, yet still as strong materials that would allow our door to be lighter.
Another way we can improve our door is by installing guides on the side to increase its stability. This would make sure the door stays center aligned on its way up and down. It would also prevent the door from spinning with the screw and from the door itself as a whole mechanism from shaking as much.
For the research phase of our project, we thought the most important things to research would be things like typical chicken coop layout, chicken behavior and habits, and the importance of a chicken coop door. The main takeaways we have from our research were that our door should most likely be made of wood because that is typically the material of choice in chicken coops, and because it is sturdy enough to protect the chickens from predators since that is one of the most important functions of a chicken coop door. We also decided that the door should be open during the day and closed at night, because chickens typically roam around during the day but need a safe place to roost or sleep during the night. Although we didn't end up placing during design day, we thought our project still performed quite well. After seeing how the judges reacted to our door, there were a few things we realized we could have improved to help make the judges like our design a little bit more. For one, we realized we hadn't cut our main threaded rod quite short enough, so it kind of stuck out a few inches from the bottom of the door and it was all the way up. This not only could be a safety issue for the chickens, but it was something that made our project look a little less professional. Also, we never really put much thought into making our project look presentable. We were mainly focused on the functionality during the construction of it. If we would have put more effort into making the project look a little better by doing something such as painting it, it could have made the judges more optimistic about our project when first seeing it. All in all though, our door functioned pretty much exactly how we expected it to. Although it was slow, all of the main functions like the light sensor and remote worked flawlessly, which was the most important part of the project.